Okay, on this problem it says get the slope of the graph f of x equals -3 times the absolute value of x minus 4 minus 2x plus 7 when x is less than or equal to the vertex point. Okay, so first let's find the vertex point. We know we get the x part of the vertex point by setting what's in the absolute value equals 0. If you set x minus 4 equals 0, you would add 4 to both sides and you get x equals 4. A lot of people would think that the y part of the vertex is 7, but it's not, because if we substitute it back in, we have this extra x term right here. So if we substitute the 4 in, 4 minus 4 is 0, and -3 times the absolute value of 0 is 0. And then finishing it off, minus 2 times that 4, that will give you -8, and -8 plus 7 is -1. So the vertex point is actually at the point 4, -1. Now this says to get the slope when x is less than the vertex point. So this x value right here is 4. Now you just substitute in any x value less than 4. So I used 3. You pick any number you want less than that vertex point, the x value of that vertex point, which is 4. So you could use 3, 2, 1, 0, anything you like. I'm going to go ahead and use 3. You can use whatever you like. Put it in 3. 3 minus 4 is -1. The absolute value makes that +1. -3 times +1 is -3. So this bit right here is -3. Continuing on with substituting in the 3, -2 times 3 is -6. So this bit here is -6, and this is +7. So we got -3 minus 6 plus 7, and if you do your arithmetic, you get -2. So now you have 2 points, and to get the slope, you can either do it by hand using the slope formula, which is difference of y's over difference of x's, and get 1, or you can take these 2 points and type them into the linear sheet right here. So the 2 points are 4, -1, and the other point is 3, -2, and make sure that it gets the equation right there, 1. So that's the way that one works. Let's go on down to this one. This one says find any x-intercepts for this function right here. Okay, now there's 2 ways. You can either do it on the AnyGraph sheet and zoom in, keep on getting closer to the x-intercepts, or you can do it by hand. Okay, I'll do it by hand, and I'll do it on the Excel sheet. To find the x-intercept, you set the y equal to 0. So we're going to set this f of x thing right here 0. Set the equation equals 0. Here it is. Now you want to isolate the absolute value. So what I did is I took this whole term to the other side, which makes it positive. Then I added 2 absolute value of x plus 3 to both sides to get this. Now you have to isolate it further by dividing through by 2. You cannot distribute through. So divide through by 2, and I get absolute value of x plus 3 equals 2.5x plus 5. That's by dividing each bit of this by 2. Now from an absolute value equation, you get 2 equations. One is x plus 3 equals 2.5x plus 5, just by dropping the absolute value. The other comes from, here I'll put this down here so you can see it. The other comes from dropping the absolute value and changing the sign of the numbers on the right. So that would be x plus 3 equals -2.5x minus 5. Now you have to solve both of these. Like for this one, you could subtract the x and subtract the 5, and then you'd have to do some division. Same way with this, maybe add 2.5x and subtract the 3 and solve these. You get 2 solutions, -4/3 and -16/7. So after you do that algebra, you get 2 solutions. That doesn't guarantee that both of these solutions are correct, because it could be that none of these work, or maybe only just one. So you'd have to substitute them back in. If you substitute the -4/3 back into the equation, right in here where we have it set equals 0, you would find that that doesn't work. That one does not work. If you substitute in the -16/7, that does work. So the right answer is actually the -16/7. Okay. So, or maybe the only one is -4/3. You'd have to check it out. But what I'm going to do is check it on the Excel sheet. So I go to the AnyGraph sheet and I type in the equation after I have it set equals 0. So I would need to type in this part right here. See, here's the equation set equals 0, -2 times the absolute value of x plus 3, and so on. So here is what I would be typing in, and I already have that typed in right here on the AnyGraph sheet. So let me double click on that. You can see what I typed in equals -2 times, don't forget the time sign, ABS parentheses, and I originally typed in x. See, after I hit enter, it replaces the x with cell A10 is what it does. But anyway, you can just type in x, then plus 3, close parentheses, plus 5 times x is what I originally had in there. and then plus 10, just like it says. Now after I type that in there, I just hit enter and it graphs it for me. Now I want to find out where that x-intercept is. So I see it's coming down, so maybe it's farther to the left. Let me just make a viewing window from -5 to 5 just to get a basic idea, and I can see that there's only one x-intercept. That x-intercept is somewhere between -2 and 0. I can see that right here. See, the x-intercept's right here. In fact, just holding the mouse cursor there, I see it's somewhere near -1.45. So it's probably between -1.5 and -1.4. Let's check. -1.5 and -1.4. Is it there? No, I didn't go far enough to the right. Maybe it's a little bit farther to the right. You can see it's coming up. Let's go clear out to -1. Okay, now we can see it somewhere right in this area. Holding the mouse cursor, I get -1.34. I go a little bit on both sides to see it a little bit tighter. How about from -1.4 to -1.3? And if I do that, I can see it's right here at -1.33, and -1.33 is the only x-intercept it has, and that is the same as -4/3. So actually, this is the only solution here. -4/3 is the only solution. This one, -16/7, does not work. So I think actually the Excel way is easier. You can see it. You just have to type it in, and then you just zoom in on that, like we did. Okay. This last example, the path of the ball, is given by this one. It's a very messy absolute value equation with a quadratic on it, and it says on this function, x is the horizontal distance and y is the height of the ball. What is the distance between the two bounces? Well, the bounces come from the x parts of the vertex points. So I'll type this one into the Excel sheet, and you see how you type it in here, but I'll go ahead and do that. So typing that equation into the Excel sheet, here is the equation again, 3 times the absolute value of 2x squared minus 3x minus 1 right here. I would type this in equals 3 times ABS, parentheses, 2 times, and you can just use x if you want instead of saying A10, x squared, carried up 2, and so on. I have it right here typed in. So you can see it. Originally I had typed in everywhere there's an A10, I had an x. So I had an x there, x there, and an x there, and then I hit enter, graph it. I have the viewing window set from -5 to 5. So the bounces are these bounces right here, and these are considered vertex points right here. Well, all I need to do, how do I get a vertex point? I get the vertex point by setting what's in here equal to 0. So really all I need to do is set 2x squared minus 3x minus 1 equal to 0 and solve it. That's a quadratic. So I can go to the quadratic sheet, put in my coefficients of 2, -3, and -1, and here's my two x-intercepts. And then getting the distance between these 2 points, we'll do that in a later section, but you could just subtract these x-intercepts right here, and that would tell you the distance. You get about, subtracting these to get the distance, you would get about 2.06. And that's actually what the distance is right here, 2.06. And chances are you won't see anything as bad as this example, but you definitely need to know how to do the problems up here in examples 1 through 5.